Let's read the problem from the beginning. Ethanol melts at negative 114.0 degrees Celsius and boils at 78.0 degrees Celsius. We write down melting point equal to negative 114.0 degrees Celsius and boiling point 78.0 degrees Celsius. The enthalpy of fusion of ethanol is 5.02 kilojoule per mole. And its enthalpy of vaporization is 38.56 kilojoule per mole. The specific heats of solid, liquid, and gas ethanol are 0.97, 2.30, and 1.75 joule per gram per Kelvin, respectively. We get three specific heats. Specific heat of solid, specific heat of liquid, and specific heat of gas. How much heat is required to raise the temperature of 42.0 gram of ethanol from 35.0 degrees Celsius to 85.0 degrees Celsius? How much heat? Heat is what we are looking for. Because we are provided so much information, I want to put down what we are looking for at a different place. The mass of ethanol is 42.0 gram. The initial temperature is 35.0 degrees Celsius. And the final temperature is 85.0 degrees Celsius. As you may have already noticed, I have assigned a symbol to every number with unit. If you assign appropriate symbol to the numbers with unit, it will be easier for you to find out which equation to use, because all the equations contain symbols, not numbers. Next, we are going to do some analysis. The initial temperature is 35.0 degrees Celsius. This temperature is between the melting point and the boiling point of ethanol. Therefore, the state of ethanol is liquid. The final temperature is 85.0 degrees Celsius. And this temperature is above the boiling point. Therefore, the state of ethanol is gas. As we can see here, during this process, we have both temperature change and phase change. But remember, we have two sets of equations to calculate the heat. The first set of equations can be used to calculate the heat whenever there's only temperature change, but no phase change. The second set of equations can be used to calculate the heat whenever there's only phase change, but no temperature change. Therefore, we need to break this process into different steps. The phase change is from a liquid to a gas. Therefore, the boiling point is a point to separate or to break this process down into different steps. For the first step, we can have only temperature change, no phase change. Then, at the boiling point, we can have only phase change, but no temperature change. Then, for step 3, we can have only temperature change, but no phase change. Now we have successfully break down the process into 3 separate steps. What I'm going to do next is to find appropriate numbers with unit for each step. For step 1, we only have a liquid. We have a temperature change. Therefore, what I need is CS liquid. For step 2, we have a phase change from a liquid to gas. Therefore, we need delta H vaporization, but not delta H fusion. For step 3, the state of ethanol is gas. Therefore, we need CS gas. Now I'm going to show you the details of each step. Step 1. We are provided the specific heat of a liquid, and we know the initial temperature and the final temperature of this step. It seems we can use equation number 1 to calculate the heat for this step. Specific heat is 2.30 joule per gram per Kelvin. The mass is 42.0 gram. The change of temperature can be calculated by using the final temperature minus the initial temperature of this step. After you punch all numbers into a calculator, we get 43.0 degrees Celsius. If it is a temperature change, 1 degree Celsius equal to 1 Kelvin. Therefore, the change of temperature is 43.0 Kelvin. We put the temperature difference here. Gram cancel, Kelvin cancel. The unit we have left is joules. We punch all numbers into a calculator, we get 4,154 joules. Now let's look at step 2. The unit of delta H vaporization is kilojoule per mole. Therefore, we want to use equation 4. But we do not know the moles of ethanol. Since we know the mass of ethanol, we can convert from mass to moles. But we need to calculate the molar mass of ethanol. For 1 mole of ethanol, we have 2 moles of carbon. If you look up a periodic table, the atomic mass of carbon is 12.01. We have 6 moles of hydrogen. And for every mole of hydrogen, it is 1.008. We have 1 mole of oxygen. For every mole of oxygen, it's 16.00. If we punch all numbers into a calculator, we get 46.068. Remember, the unit of the molar mass is gram per mole. Now we will convert the mass into moles. Gram on top, therefore we need to put gram at the bottom. Gram cancel. We will get moles, which is 0.912 moles. Then we need to use equation 4. Q equal to 38.56 kilojoule per mole. Multiply 0.912 mole. Since the unit for step 1 is joules, we want to make sure the unit is the same for all steps. Let's convert this into kilojoules. Joules. 1 kilojoule equal to 1000 joule. Mole cancel, kilojoule cancel. We will get joule as our unit. The answer is 35,167 joules. Since we have 3 different steps, we want to label the heat for step 1 is Q1. And this is Q2. Now we are going to calculate the heat for step 3. For the same reason as in step 1, we need to use equation 1. The specific heat is 1.75 joule per gram per Kelvin. The mass is 42.0 gram. And the temperature difference is using the final temperature minus the initial temperature of step 3. The change of temperature is 7.0 degrees Celsius. Remember, if it is the change of temperature, 1 degree Celsius equal to 1 Kelvin. Therefore, the change of temperature is 7.0 Kelvin. We put the change of temperature here. Gram cancel, Kelvin cancel. We will get joules, which is 515 joules. To calculate the heat of the entire process, we need to add the heat of 3 steps together. The heat for step 1 is 4,154 joules, plus the heat for the second step is 35,167 joules, plus the heat for the third step is 515 joules. We will get 39,836 joules. And this is about equal to 3.98 times 10 to the 4th joules. At the end, I want to emphasize, this part is all I need during an exam or a quiz. You do not need to show me this part. But it is always a good idea to put down this